This is pre-calculus math analysis, and we're talking about derivatives. Last time we talked about the definition of a derivative using limits, and then this time we're going to talk about what's called the power rule. How do you take a derivative of a function that has an exponent? So, for example, x squared. I'm just going to use this definition, the limit as h approaches 0 of f of x plus h minus f of x divided by h. That is a definition of definition of a derivative using limits. And I'm going to use this function x squared. So this should equal x plus h squared minus x squared over h, and that's going to be x squared plus 2xh plus h squared minus x squared over h. Now the limit, we have x squared and minus x squared. Now the limit as h approaches 0 of 2xh divided by h, well, the h cancels out. So now we're just left with 2x. And I want you to notice that our original function was x squared, and our derivative, f prime of x, is 2x. Notice that there is a relationship where this exponent moved to the front of the function, and then all I did was actually subtract one of the exponents. So technically I could write this as 2x to the first power. So in general, the power rule is given by if f of x equals x to the nth power, then f prime of x is equal to n x to the n minus 1 power. So that's the rule that I'm going to use for each of these problems here. So now, if I look at the first one, which says f of x is equal to x, then f prime of x is going to be 1x to the 0 power, which is just going to be 1. For this one, we got an answer of 2x. And then the next one, if I have x cubed, then f prime of x is going to be 3x squared. And then you can begin to pick up the pattern. One, 2x, 3x squared, 4x to the third, and then finally we'll see what they want here. This is going to be nx to the n minus 1. All right, there you are. That's question number 1. Let's look at question number 2. Suppose that you have a function that is just a constant, Determine the derivative of y equals 9 with respect to x. I can do this the long way and say that the f prime of x is going to be the limit as x approaches, as h approaches 0 of f of x plus h minus f of x divided by h. Well, in this problem, the function is y equals 9, so f of x is equal to 9, and there is no x value. So what happens is we get x plus h, there's nothing to plug in, so this turns into 9 minus 9, which is just 0. So anytime there is a constant, the derivative is going to be 0. All right, don't forget that you need the y prime. Let's do another. Question 8. Consider the function y equals square root x. Rewrite the function in exponential form. We have to remember that y equals root x is the same thing as writing y to the equals x to the 1/2 power. So square roots are fractional exponents. Now let's find the derivative y prime. But let's just use the same power rule. So if y equals x to the 1/2, then y prime, which is also f prime of x, means the same thing. We're going to move the 1/2 to the front, and then subtract 1 from the exponent. So this is going to be negative 1/2. And it just depends on how you have to enter this function into the system. All right. So then we just have to write it in the correct form. And also notice that dy over dx is another way to write y prime. So these two are the same thing. 1 over 2 root x. All right, there you have it. Please work on these power rule questions, and then have a nice day.